Math in roller coasters. Roller coaster engineers use several computer programs which allow them to efficiently design and test roller coasters. One commonly used program is AutoCAD. It allows engineers to digitally construct 3D and 2D models. This program is also used for other engineering applications. EngineSoft is another example which is used. It combines CAD, which is computer-aided design, with CAE, which is computer-aided engineering. This program allows the engineers to design prototypes and also assess the effects of real-world conditions on the passengers, like the different accelerations, G-force, friction, that might have effects on the passengers and cars during a roller coaster ride. And so some shapes of roller coasters include a clothoid loop, which is a section of a spiral which has a constantly changing radius. The radius at the bottom of the loop is larger than the top, or you can look at it as the radius of the curvature is inversely proportional to the distance, S, from the center of the spiral. And so in order to create like variations in loop sizes, a set of differential equations is used when input in these software programs. So there's the equation. And then, so the reason that clothoid loops are more common than circular loops is because the acceleration of a clothoid loop has variations depending on where it is on the loop. Whereas in a circular loop, it's more of a constant acceleration and it has a more aggressive effect on the rider. And the clothoid loop is a more like comfortable ride. And so some trigonometric functions which can be used are sine, cosine. You can use parabolas, cardioids. So parabolas can be used. This is the standard equation of a parabola. There's the two. So they can make variations with different slopes. And so in order to create variations, they use multiple parabolas, again, with the different, heights. And they use these as piecewise functions. Sine can also be used, except when inputted into the programs, they have to use the limits of the periods. And again, they can create variations with the amplitude of the functions. Cosine is similar to sine, where they have to limit the periods. And again, they can create variation using the amplitude. And so again, there's the equation of cosine. Cardioids can be used, but they have to limit the the y on the y-axis and the x-axis. So there's the formulas for all of those that can be used in some roller coasters. So engineers also use a couple other equations that don't have to do with the design specifically. And one of these is the approximate speed. So they use this equation to find the approximate speed of the roller coaster at a specific point. And so to do that, they find the square root of 2 times the gravitational pull, which is a constant, and height at that specific point. They also use centripetal action. So around a loop, the equation is equal to the velocity squared divided by the radius. And then the centripetal action around a twist is equal to the rate of the twist squared times the radius of the twist. And the rate of the twist, or W, is in radians per second. And G-force is a very important calculation for roller coasters because if it goes over a certain G force, it can actually result in the passengers fainting or blacking out and can result in an unenjoyable ride. So in order to find the G-force, you first have to find the acceleration, which is equal to the final velocity minus the initial velocity over the period of time, which is then plugged into this equation to find the force the roller coaster exerts on the passengers, which is equal to the mass times the acceleration. And then in order to find the force of gravity, the gravitational constant, which is 6.67 times 10 to the negative 11th, is multiplied by the person's mass and the Earth's mass and divided by the radius of the Earth squared. And so they use the average weight or the average mass of a person in America, which is 70 kilograms. And then for Earth's mass, they use 5.976 times 10 to the 24th kilograms. And for the radius of the Earth, they use 6,378,000 meters. And so finally, they divide the force applied by the roller coaster by the force applied by the Earth, or in this case, step 1.1 divided by step 2. And that is all.